Welcome to this explainer. Today, we're diving into, well, honestly, the ultimate mystery of physics. Think about it for a second. At the microscopic level, our universe is governed by the totally bizarre, probabilistic rules of quantum mechanics. Things can literally exist in multiple states at once. But then, look around you. The solid, stable reality we experience every single day, the chairs we sit on, the screens we're looking at, it all behaves completely predictably. So, how does the universe bridge that massive gap? How does the weird quantum realm actually transform into classical reality? Let's unravel exactly how the universe pulls off this incredible magic trick.
All right, so let's kick things off with a paradox that basically breaks the fourth wall of quantum mechanics. We know that subatomic particles can exist in a superposition, right? But if absolutely everything in the universe is fundamentally made of these quantum particles, why on earth don't we see that on a macroscopic scale? Like, why doesn't your dinner exist in a superposition of states?
It's a hilarious thought experiment, taking quantum superposition right into our kitchens. Just imagine a chicken that is simultaneously raw, actively cooking, and, I don't know, running around completely alive. It's an absolute nightmare for a chef. But in physics, this absurdity highlights what's famously known as the measurement problem. If the superposition principle says that every combination of quantum states is a perfectly legal state, why do we never, literally ever, experience a world that looks like that? Why does the universe seemingly force a choice? This paradox really sets up a stark contrast between two seemingly completely incompatible domains. On one hand, we've got the quantum realm. It's totally defined by fragile probabilities, superpositions, and, just inherent uncertainty. But then, on the other hand, we have our classical world. This is the world we actually live in. It's built on definite states, objective reality, and rock-solid stability. For the longest time, physicists seriously struggled to explain how we get from point A to point B. Like, what is the actual mechanism that filters out all that quantum weirdness? That brings us to Section 1, Introducing Quantum Darwinism, the environment as the ultimate selector. Let's get right into it. So, for a really long time, physicists basically blamed the conscious observer for collapsing these strange quantum states. You look at it, it collapses. But physicist Wojciech Zurek, he offered a new, honestly much more pervasive culprit, the environment itself. It's kind of like Charles Darwin's survival of the fittest, but applied to the literal building blocks of reality. Just like in natural selection, the universe is running this massive continuous selection process. Think of those fragile superpositions, like our half-cooked, half-alive chicken, as really weak branches on a tree. When the storm of the environment hits, when light, heat, or just random air molecules bounce off of them, those fragile branches just snap. The environment ruthlessly prunes them away. And what's left? Only the most robust, incredibly stable quantum states actually survive the interaction. Now, the absolutely crucial point here is understanding these survivors. Physicists call them pointer states. You can think of them as the unshakable trunks of the quantum system. When they get bombarded by environmental noise, whether that's a sea of photons or just colliding air molecules, these pointer states remain incredibly stable. They don't lose their identity at all. They're essentially the quantum equivalents of the classical, everyday states we're so used to experiencing. They survive that whole process of decoherence, just standing firm while all the other delicate, weird quantum possibilities completely wash away. And the stability of these pointer states? It relies heavily on a kind of deep entanglement structure. It's fascinating how the system and the environment become so perfectly correlated. You see, in a classical sense, probability often just comes from our own subjective ignorance, right? Like not knowing which card is hidden in a deck. But in the quantum world, probability and these resulting pointer states actually emerge from an objective symmetry. The system and its environment entangle perfectly. You don't need a conscious observer's subjective ignorance to make the math work anymore. The physical interaction itself writes the rules of what survives. So to see exactly how this crazy engine of reality operates, let's just walk through the chronological steps of quantum Darwinism. Step 1. We start down in the quantum realm, where particles exist in that super fragile superposition of multiple states. Step 2, the environment, which, remember, is literally everywhere, constantly interacts with the system. Light hits it, air molecules bump into it, you name it. Step 3, this constant interaction causes decoherence. The fragile multi-state possibilities are slowly, ruthlessly destroyed, leaving behind only our robust pointer states. And finally, step 4, and honestly, this is where the magic really happens, the environment takes these surviving states and broadcasts them as multiple replicas out into the universe. This sequence perfectly captures Zurek's central argument.
For the longest time, the environment was viewed purely as destructive noise, just something annoying that ruined quantum coherence. But quantum Darwinism totally flips that on its head. The environment is actually a massive communication channel. It acts as an amplifier. Once it prunes away all those fragile states, it takes the surviving pointer states and imprints them over and over and over again. It broadcasts this one distinct branch of reality out into the world for anyone or anything to perceive. To really grasp the sheer scale of this environmental broadcasting, I want you to consider a truly mind-bending number: 100 million. Picture a single grain of dust, just 1 micrometer across. If that tiny speck is illuminated by the sun for a mere 1 microsecond, its location is imprinted into the scattered photons 100 million times. In a literal fraction of the blink of an eye, the universe has made 100 million exact replicas of that dust grain's position and scattered them in all directions. No way, right? But it's true. And that brings us to the sheer power of redundancy. This mind-blowing redundancy is exactly what ensures our everyday sense of objective reality. Because millions of replicas are constantly scattered into the environment, you only need to sample a tiny distinct fraction of that environment to know exactly what's going on. 10 different observers could stand in a room, intercept completely different sets of photons bouncing off a coffee mug, and they would all completely agree on exactly where that mug is. Interestingly, though, the medium really matters here. Photons are basically excellent witnesses because they faithfully pass on information, just gliding cleanly without interacting with each other. Air molecules, on the other hand, well, they do a great job of decohering a system, but because they constantly and chaotically collide with one another, they can actually scramble the data over time. But thankfully, because of photons, the redundancy remains intact, and we get a reliable, shared world.
Okay, moving on to Section 2, the emergence of objective reality, consensus over existence.
So we've gone from fragile superpositions to robust pointer states, and finally to this massive environmental broadcasting. But what does all this actually mean for our fundamental understanding of existence? Well, it leads to a pretty profound conclusion. We normally think of a speck of dust as having an objective position because, well, that's just how the universe is. But quantum Darwinism tells us something so much deeper. It has a position because its state was robust enough to survive, and it imprinted so many identical replicas of itself into the environment that you, me, and literally everyone else can reach a consensus about it. Objective reality isn't just a static what is. Actually, scratch that. It's more like a consensus of surviving quantum information that multiple observers can independently tap into. I'm going to leave you with this provocative thought to ponder today. We look around and we see a perfectly stable, definite world, but underneath it all, there is a roaring quantum storm. If everything we see, touch, and measure is simply the fittest information that managed to survive environmental pruning, are we all just tuning in to the universe's ultimate continuous broadcast? Definitely something to think about the next time you look at a simple speck of dust. Thanks so much for joining me for this explainer, and as always, keep questioning the reality around you.